Welcome to The Explainer. Today, we're going to unravel a really surprising story, one that connects the threads of a 19th century loom directly to the code running on your computer right this second.
So, what is the link between a textile loom and a laptop? I mean, on the surface, they seem like they're from different planets, right? One weaves actual physical fabric, the other crunches digital information. But the connection between them? Oh, it's not just real, it's absolutely revolutionary. It all comes down to this, a simple piece of paper with holes in it. Yep, that's it. This is the story of the punched card. And believe it or not, this humble little thing programmed our entire world way before the first computer was ever built.
All right, so our journey starts in the early 1800s. The textile industry is just exploding. It's booming. But they've got this huge problem, a real bottleneck when it came to making anything with a complex pattern. It was not just inefficient, it was dangerous.
You see, before this time, weaving anything complicated was just grueling. I mean, they had these young assistants, they called them drawboys, who would literally sit perched on top of these massive looms, manually lifting super heavy reeds to create the design. The process was ridiculously slow. We're talking maybe 5 centimeters of fabric in a whole day, and it was incredibly dangerous work. But then, a French inventor, Joseph-Marie Jacquard, well, he was about to change the entire game.
What Jacquard did was create this amazing automated system that you could just attach to a loom. And his device, it could read instructions from a long connected chain of punch cards. Think about it. Each card was basically one row of the design. So the whole chain of cards, well, that was effectively the world's very first program for creating these beautiful, intricate fabric patterns.
And the logic behind it was just genius in its simplicity. So a card gets pressed up against a bunch of needles. If a needle lines up with a hole, boom, it goes right through and lifts up a specific thread. But if there's no hole, the needle gets blocked and that thread stays put. This really simple binary system of hole or no hole meant you could automatically create literally any pattern imaginable.
Okay, but the truly brilliant part here wasn't just making looms faster. No, the real innovation, the big idea, was that you could store and execute a set of instructions on a physical thing. And that concept, it was about to take a massive leap into a whole new world.
And this is where the story gets really interesting. You have these visionaries, right? People like Charles Babbage and the amazing Otto Lovelace. They look at the Jacquard loom, and they don't just see a machine for making fabric. They see something so much bigger. They realized, wait a minute, if we can use these cards to control threads, why can't we use them to control numbers or symbols or even logic itself?
And right there, that was it. That was the spark, the intellectual birth of the computer program. This whole idea that a machine could follow a pre-written set of instructions to perform complex calculations, it was born right there in the noisy clatter of a textile mill, decades and decades before a single electronic computer even existed. It's wild.
And, this core idea was so incredibly powerful, it's still in use today. I mean, a mechanical loom from the late 1800s might have had, say, around 1,200 hooks controlling the threads. But a modern electronic Jacquard loom, using a system they call CompuJack, it can control almost 5,000. The technology has obviously evolved, but that fundamental principle of programmable control, it remains.
So this amazing ability to store instructions soon found a brand new and absolutely critical application. So let's jump forward a few decades, where the punch card isn't just weaving patterns anymore, it's processing information.
By 1890, the punched card was about to solve a national crisis. The U.S. Census Bureau was literally drowning in data. The country's population was just exploding, and they feared that crunching all the numbers from the census would take more than a decade to do by hand. The data would be totally obsolete before they even finished counting it.
I mean, get this. The previous census took 8 years to complete. 8! So an inventor named Herman Hollerith comes along and proposes a new system using punched cards to store data and electromechanical machines to count it all up. And the result? Staggering. The 1890 census was finished in just 1 year. It saved the government millions of dollars and proved without a doubt the incredible power of automated data processing.
And that success, it launched an entire industry. Suddenly you had these machines called key punches propping up. You had armies of operators whose whole job was to translate raw information into patterns of holes on these cards. This entire ecosystem of punching, sorting, and tabulating data gave birth to new companies, including one you've probably heard of. It would eventually become the computing giant IBM.
But these data entry machines, they had this really peculiar and honestly kind of revealing nickname.
All right, let's connect the final dots in our story. This is where the whole thing really comes full circle. They were called piano machines, and that wasn't just some random nickname someone came up with. No, it was actually the perfect description of how people interacted with the technology. See, the name came from its keyboard-like interface. The operators would literally play the data onto the cards, just like playing a piano, using the keys to activate the different punches. It's this fascinating bridge, right, between this heavy industrial tool and a musical instrument. And that bridge was a super important step on the road to the modern computer keyboard we all use today.
So when you look back, the legacy of the punched card is just immense. I mean, think about it. It was the first widely used form of programmable automation. That whole stack of cards, that was basically the first version of read-only memory, or ROM, a program you could run but not easily change. It established the very ideas of data storage and software. And maybe most importantly, that simple whole versus no-hole system. Well, that's the direct ancestor of digital binary code, the ones and zeros that power our entire digital world.
So from threads to code, this simple invention literally wove the very fabric of our digital world. The next time you write an email or stream a video, just remember that the origins of that software can be traced right back to the clatter and the rhythm of a 19th century textile mill.
And that leaves us with a pretty interesting question to think about, right? What simple technology that we use every single day without a thought is going to be the blueprint for tomorrow's big revolution? That's a thought to take with you from this explainer. Thanks for watching.